So, if there is a line of symmetry, your centroid is located on it. If the shape has some sort of line of symmetry, your centroid is located on line of symmetry. To give you an idea, let's do some simple shapes. We'll start with a little 3x3 square. And if it has two lines of symmetry, the centroid has to be at the intersection of those two lines. So we can do the same thing with a circle. Let's give us a circle with a diameter of 3. So we'll go up and down 3, and we'll go to the left and the right 3. 4 straight lines, and we'll connect these straight lines with curve. Circle doesn't have to be perfect, just get the idea down. And then we can draw our intersecting lines of symmetry. And of course, the centroid will be located at the intersection of those two lines of symmetry. But what if a shape only has one line of symmetry? So what if we drew ourselves an isosceles triangle? We say, okay, we draw it with a base of 2 and a height of 3. A triangle with a base of 2 and a height of 3. There's only one line of symmetry here, right down the middle. Well, the centroid is going to be on this line of symmetry, but this shape is more bottom heavy. Therefore, the centroid will be closer to the bottom than it is to the top. And so if there's only one line of symmetry, you know one of the components of your centroid, just not the other. Now, this is looking at 2D shapes. Something you need to keep in mind is that centroids are very much 3D. Centroids are found at the average center of the X, Y, and Z directions. Of the X, Y, and Z directions. Now, a rule you need to follow when finding centroids, or to find centroids, you need a consistent reference point. Which I will henceforth label with just an RP. So, parentheses RP. So, to discuss the idea of a reference point and what we're actually doing, go ahead and skip 2 squares, and off to the left, draw yourself another 3x3 square. So, we're going to draw the same square as the one above, but this time let's make it 3D. So, we'll just make it a rectangular prism, adding oblique to the sketch. No, oblique aspect, I guess I should say. Going back one diagonal for each one of these, and then connect the backs. So now we've got this 3D rectangular prism. You need to decide what reference point you want to measure. A good standard to pick, if you're just going to pick, it doesn't really matter, but I like to pick the bottom left. That way it always goes up and to the right. It makes measuring a lot easier for me, but it doesn't have to be bottom. In fact, there will be some examples where it's on the right instead in your activity. But we'll call this our reference point. It's just a place to measure my 3 directions for my centroid. And so we could do the same thing. We could draw ourselves a triangle. And this time, draw yourselves a right triangle that has a height of 3 and a length of, or base of 4. And you just connect it. And then again, we'll make it oblique by adding these two corners and then just connecting those. Again, I'm going to pick my reference point. It's just a starting point to measure from. And for the last one, instead of doing this weird, or the circle is easy, but let's do a half circle instead, because you're going to see this example a lot. You're going to see it a couple more times in your notes and in the activity as well. So you need to know how to calculate out the centroid or a half circle. So now's a good place to start drawing it at the very least. So we'll draw our 3 straight lines and connect them with curves. Then we can go back 1, and then go back and up 1 to draw the next center. This is easy. The hard part is finding that tangent for where this changes direction. Stops being a straight line, starts being a curve, but it doesn't need to be perfect. Hopefully you get the idea. This is just a half circle, half sphere, I guess I should say. You just had a little, not sphere, cylinder. You just cut it in half. But let's give it a reference point as well at the bottom left. Now, let's draw ourselves a little axis. Obviously, y direction is going up. When I say x, y, and z direction, this is obviously y. X is obviously going to the right. And z is going forward and back. So what am I saying? Well, from my reference point, how far away would my centroid be in the x direction for this circle? Can y'all tell? From this reference point on this rectangular prism, how far would my x be? The centroid be in the x direction, I mean. 1.5 squares. And how far would it be in the y direction? 1.5 squares. But do y'all agree that this centroid clearly would not just be on the side of this front face? It would be in the middle of or from front to back as well. It would be back here, intersecting with these two. It wouldn't be on this front face as we just drew it, but it would be inside our shape. And so that's what I mean when I say it's the center in all 3 directions. What's the point of the reference point? I'm measuring in the x direction. From my reference point, I'm measuring in the y direction, and then I'm going to measure in the z direction as well. And that's what we are talking about. So, when you see this symbol, an X with a line over it, when we're talking about centroids, what it's saying is, what is the X distance? The X distance from our reference point to our centroid. The Y symbol means the same thing, but the Y distance from our reference point to our centroid. And I drew my Y a little bit too big. I'm going to skip a line. But for our Z, the same thing. It's our Z distance. If you see the Z with the line over it, that is. It's the Z distance from our reference point to our centroid. I'm going to go to the next page. I'm going to let you be the judge of whether or not you need to.